Hi there, welcome back to a new recording. This is Jihad Hamasai, a high school chemistry teacher. In today's recording, I'll be talking about the aqueous solution and concept of pH. We will be talking about how to calculate pH, pOH, hydronium hydroxide of the solutions, the relation with temperature, and then at the end of the session, we will be solving some of the ministerial exam questions, guys. Let us start with the self-ionization of water, guys. The water molecules, when we talked about the neutralization reaction, guys, we said the neutralization reaction in section 2 is a reaction between hydronium and hydroxide, hydronium from the acids, hydroxide from the bases, to form H2O molecules. The self-ionization of water is a unique property of water which we have when we have pure water, guys. The pure water, there are two water molecules. One of the water molecule is going to donate a proton to the other one to form hydronium, and then the remainder will be the hydroxide. In this reaction, guys, the H2O molecule, the first one acts as a Bronsted-Lowry acid, and then the second one acts as a Bronsted-Lowry base. So this is the only reaction that the water acts as what? As both acids and bases. It can be, we can say a statement about water in this reaction. It acts as amphoteric in this reaction when it reacts to form hydronium and hydroxide. Itself ionizes with itself, reacts with itself. That's why we call it a self-ionization of water, guys. When we have the formation of hydronium and hydroxide in pure water or the other solutions, guys, there is a quantity we call as the ion product constant, or constant ionization of water, guys, represented by the Kw. The Kw is a constant value which can be calculated through the multiplication of hydronium and hydroxide. It represents the ionization degree of the pure water molecules, guys. As the ionization degree increases by increasing temperature, we'll be talking about the relations with temperature, guys, that gonna increase the Kw values, guys. So at 25 Celsius, we should know that the Kw value is equal to 10 to the power minus 14, and then the hydronium and hydroxide individually, they equal to the power 10 to the power minus 7 molarity, guys. This is at 25 Celsius. This value can be changed and vary according to different temperatures, guys. Let us talk about the types of the solutions in terms of the acidic, basic, and neutrals. Guys, we have got three types of solution in terms of the acidity, hydronium and hydroxide concentrations. The one that we call as the acidic, always it has got a higher hydronium than the hydroxide, and then at 25 Celsius, these values are at 25 Celsius, guys. They are true at 25 Celsius. Its pH is less than 7, pOH more than 7. We'll be talking about pH and pOH in detail, guys. But the neutral, they have got their solution, they are equal in concentration of hydronium and hydroxide, and pH and pOH equals to 7. The basic solution is just the opposite of the acidic solution, which has a lower hydronium than the hydroxide, higher pH value, but a lower pOH value than 7, guys. These are the basic differences between the acidic, neutral, and basic solution, guys. At 25 Celsius, we can determine the quantities of the hydronium and hydroxide for each of the following, but these values are only true at 25 Celsius, guys. We can say for the acidic solution, hydronium concentration is more than 10 to the power minus 7. Hydroxide is less than that value, 10 to the power minus 7. But for the neutral solution, both hydronium and hydroxide, they equal to the what? 10 to the power minus 7 at 25 Celsius. And then for the basic solution, the hydroxide concentration is more than 10 to the power minus 7. We mean the hydronium is less than 10 to the power minus 7. These values are only true at 25 Celsius, but the first relations, guys, they're always true. Let us talk about the pH scale, guys. The pH scale is a scale of measurement ranged between 0 to 14. It measures the acidity, alkalinity of the solution through the values which we call as the pH values. It's difficult or complicated to represent the acidity and alkalinity of the solution through the hydronium and hydroxide value because they are too small values, 10 to the power -1, -2 till -14. These are the small values, which dealing with those values is a little bit confusing. Instead of that, the scientists, they have created a scale to measure the pH or to measure the acidity, alkalinity, hydronium and hydroxide through an easier scale which we call as a pH scale. Guys, the pH scale, pH refers to the power of hydrogen. So the power of hydrogen, which represents by pH, it ranges between 0 to 14 as we said. Between 0 to 6.99 it's acidic. At 7 it's neutral. Above 7, which we mean 7.01 till 14, it's basic, alkaline. Guys, as pH increase, what will happen? What will happen to hydronium, hydroxide, alkalinity, acidity? We should know that there are two directions. As pH increase in this direction, 3 values are going to increase, the other 3 values are going to decrease, guys. Those 3 values are going to increase as pH increases, the hydroxide concentration increases, and then the alkalinity increases, guys. So here we represented the alkalinity, hydroxide, and the pH increases, but the hydronium in this direction, these 3 are going to increase, but the hydronium, pOH, and then acidity decreases as we go approach or as we approach toward the 14, guys. In the opposite, as the pH decreases, guys, as the pH decreases, what will happen? The pH decreases in this direction, okay? The hydronium, okay, hydronium concentration, here I have written, guys, hydronium concentration increases, the acidity increases, and then the pOH increases as well. But the 3 other values are going to be decreases, the hydroxide, alkalinity, and then the pH value. This is very important, these relations, in order to answer the types of question, which of the following is the most acidic? Which of the following is the most basic, most alkaline? Has the highest pH, has the highest pOH, has the highest hydronium, has the highest hydroxide? A simple example let me provide, guys. For example, A if it is ammonia, B if it is HCl, C if it is H2O, D if it is KOH. If there will be questions, you can create such options to yourself and practice several questions, guys. We'll be answering the questions and then mention the question and answering them. Which of the following has the highest pH value? Of course, the highest pH value is D because it's the most alkaline. Which of the following has the least pH value? Of course, the least, this is the highest, and that one the least pH value because it's the most acidic. Which of the following has the equal pH with pOH and hydronium and hydroxide? The pH here equals pOH for H2O because it's neutral. Hydronium equals hydroxide, it's neutral. Which of the following has the highest hydronium? Highest hydronium means most acidic, so the highest hydronium is HCl, guys. So hydronium concentration is the highest in HCl. But the highest hydroxide concentration here is the highest for KOH, is highest. The least hydroxide, HCl. The least hydronium, KOH. So that are the types of questions. You can provide options in order to solve such questions based on the provided pH scale, guys. Here we'll be talking about the equations which we will be using to calculate the mathematical questions, guys. There are 6 equations, guys. We studied the first one. We said Kw equals hydronium multiplied to the hydroxide. That can be used to convert hydronium to hydroxide and hydroxide to hydronium. And the other equations, we have got 5 more equations, guys. To convert between hydronium to pH, hydroxide to POH, and then vice versa, guys. The first equation here, we can see that it's the pH, calculating the pH through the hydronium, which will be taking the negative log of hydronium. If you want to convert the hydronium into, or the pH into hydronium, guys, we'll be taking the 10 to the power minus pH, that results the hydronium, or antilog of minus pH results the hydronium. If we want to convert the hydroxide into POH, guys, we can use this equation, that negative log of hydroxide represents the POH, or if we want to calculate the hydroxide from the POH, we can use this equation, which represents the 10 to the power minus POH, or antilog of minus POH. And the last equation can be used to calculate or to convert between hydronium to hydroxide, pH to POH, POH to pH. pH and POH summations always must be equal to pKw, which is 14 at 25 Celsius. So we can say that pH and POH at 25 Celsius always must be 14. This is true at 25 Celsius. This can be changed in different temperatures, guys. So we will be talking about the relations. Now it's time to talk about the relations, guys. Relation of what? Relation of pH, POH, pKw with temperature, guys. Here the graph represents the relation. The black, this dashed graph represents what? The pKw. And then the orange one represents the pH, POH, and then the green one represents what? pH. As you can see, all these 3 values are going to be reduced. There is reduction in those values as the temperature increases. So the pH, here I have written those quantities, guys. The pH, POH, and pKw, they have an inverse relation with temperature, 1 over T. So always as the temperature increases, there will be reduction in pH value, POH value, pKw value. As temperature reduces, there will be elevation in those values. But among the pH and POH, pH is inversely with POH. You should know that, guys. As pH increases, the POH reduces, and then vice versa. We'll be talking about another relations, another group with temperature, guys. The group of Kw, hydronium, hydroxide, ionization, guys. The relations between this group is directly proportional with temperature, guys. As you can see, it represents for Kw, and we can say another quantity, hydronium, because it increases with Kw, and then hydroxide concentration, and then ionization. These 4 quantities. Guys, these 4 quantities, hydronium concentration, hydroxide concentration, Kw, and ionization degree, they are all directly proportional with temperature. As temperature increases, those values increases. But we should know that the hydroxide and hydronium, they are inversely proportional with each other. Inverse. As hydronium increase, the hydroxide must reduce to get the same quantity of the constant value of Kw. Whenever there will be a multiplication between quantities, those 2 quantities, they are changing inversely proportionality. Guys, the about the ionization, the self-ionization of water, it's in the endothermic process. Endothermic process means the delta H is positive. And then according to Le Chatelier's principle, we'll be talking in chapter 6, as temperature increase, that means represents by the positive sign, increasing. These two signs, whenever they're equal, there will be a forward direction will be a favorite. As forward direction will be favored, that means the water molecule ionizes more, that increases the ionization, and then the concentration of hydronium and hydroxide elevates both equally in the solution, and then that increases the Kw value. They're all working as a chain, they all affect us on the other. As the ionization increases, that increases hydronium and hydroxide, and then eventually that increases the Kw value, guys. And we should know that whenever we'll be taking the negative logarithm between something that equals to the negative logarithm of the other, they are changing inversely proportional, guys. For example, A equals negative log of B, that means A and B are changing inversely proportional. So we can state another direction between hydronium pH. Hydronium and pH, they are changing inversely proportional. And then hydroxide with pOH are inversely proportional, guys. But hydroxide with pH are directly proportional. And then hydronium with pOH are directly proportional to each other. These are very important, these relations, to be known in order to solve the types of the questions, guys. We talked about the relations. Let's talk about the types of the salt, which are important to be known. In chemistry, we have got 4 types of salts, guys. The acidic, basic, neutral, and the 4th type can be acidic, basic, neutral, based on the ionization constant of water, guys. The first type is acidic salt, guys. As you can see, the acidic salt is a salt that made up from the strong acid with a weak base. A strong acid with a weak base. By the way, salts are the ionic compounds that they made up of the cation of base plus the anion of the acids, guys. Anion of acids. If the cation from the base is from a weak base and then the anion is from the strong acid, that becomes an acidic salt. Which side is more acidic or which side is stronger, that the salt classified based on the strength of the side. And then you know that the acidic salt has a less pH than 7, or its pH less than 7. It will go through cation hydrolysis. We'll be talking about the hydrolysis in chapter 6, guys. And then examples for that: NH4Cl, CuSO4. As you can see, NH4 obtains from ammonia, and then HCl from HCl. You can see that, you can observe the HCl is a strong acid, and then ammonia is a weak base. Copper hydroxide, CuOH by 2, which is a weak base, and then H2SO4, which is a strong acid, guys. The second type of the salt is what is a basic salt, guys. The basic salt, unlike the acidic salt, is what has its cation is strong base, the anion from a weak acid, guys. This type of salt, they undergo through anion hydrolysis, and then the pH is more than 7 because they are basic. And then examples we can provide it here: CS3COONA, CS3COO, it obtains from CS3COOH, which is acetic acid, and Na from NaOH, which is sodium hydroxide, a strong base. Sodium hydroxide with the H2CO3, which is a carbonic acid. The carbonate obtains from the weak acid, and then the sodium from the strong base. Guys, the third type is what is the neutral salt, guys. A neutral salt is a salt that both cation and anion obtained from the strong acids and strong bases. So strong acid and strong base combinations, cation from strong base, anion from strong acid, form a neutral salt. A neutral salt is neutral. Its pH equals 7. that means pOH equals 7, neither cation nor anion hydrolysis. It does not undergo through anion and cation hydrolysis. Example, NaCl, KNO3, they are obtained from strong acid and strong base. And the last type of the salt, which obtained from weak acid and weak base, unlike the neutral, guys, this salt can be acidic, basic, or neutral. Its pH depends on the values of Ka and Kb value. The Ka and Kb value, we'll be talking about them in chapter 6, constant ionization of acids and constant ionization of bases. There we will be talking about those quantities. If the Ka is more than Kb, that means it's acidic. If the Kb is more than Ka, that means it's basic. And then if they are equal, that means it's a neutral, but it undergo through both cation and anion hydrolysis. Example like CS3COO NH4. CS3COO we obtain from acetic acid, and NH4 from the ammonia, guys. It's time to talk about how to solve questions, mathematical questions. I'll be solving a question, but prior to solve the question, we should know this note, guys. The note represents that whenever the concentration of the strong acid and strong base are provided, we should know how to convert into hydronium and hydroxide. You should keep in mind that when the concentration of strong base is given, direct we can convert into hydroxide, and then concentration of the strong acid can be converted into hydronium directly. Here we'll be talking about how to perform the calculations simply. If this from 1OH group 1 plus strong base, it's like lithium hydroxide, sodium hydroxide, exactly equals the hydroxide concentration. The concentration will be hydroxide. But if it is 2OH, like calcium hydroxide, the barium hydroxide, strontium hydroxide, we should multiply the concentration of the base by 2 to get the hydroxide concentration, because the hydroxide will be twice as the concentration of the base. If the monoprotic acid, which is one like HCl, HBr, HNO3 and so on, direct we can convert into hydronium, they're equal. But if it is diprotic, we should multiply to 2 in order to get the hydronium, because diprotic, like H2SO4, H2CrO4, they're producing 2 hydronium as the concentration. Here, let us practice the sample problem. Here, 0.05 concentration molarity of KOH is given from the KOH, which is 1OH. So we can say that direct, we calculated we observed the hydroxide concentration. So hydroxide exactly is equal to the first step, we can determine the hydroxide. But if it was HCl, for example, we can determine hydronium direct. And then the second step will be converting the hydroxide to hydronium by using Kw. You know that the Kw at 25 Celsius, of course, will be performing this calculation at 25 Celsius. Equals 1 to the power minus 14 over the hydroxide, results this value of hydronium. How to convert the hydronium and hydroxide to pH and pOH? We can convert the hydroxide into pOH by using the negative log of hydroxide, results 1.3 pOH. And then by the summation of those two values, pH plus pOH equals 14 at 25 Celsius, we can convert the pOH into pH, which is 12.7. This 12.7 pH represents that the solution is a strong base, is alkaline solution, guys, which is the property of KOH. Let us solve ministerial exam questions. It's time to solve practice ministerial exam question to know how it appears in ministerial exam questions, this section. Which of the following is correct at all temperature in pure water, guys? This is a ministerial exam question, 24-25 rounds of ministerial. That, guys, to solve this question, we should know that the equations are true for all temperatures, but the other values in terms of 10 to the power minus 14, minus 7, minus those quantities, they can change, vary according to different temperature. So Kw equals hydronium multiply hydroxide. It's true at all temperature, but at all temperature, this multiplication is not equal to 10 to the power minus 14. It's only at 25 Celsius. So B is incorrect. And then they are not equal to 10 to the power minus 7 at all temperature. So the A is the correct answer. The second question said, if 1,000 liters of aqueous solution contains 2 to 10 to the power minus 5 mole of hydronium, the mole is given and then the volume is given, we should calculate the concentration of the hydronium, guys. When the concentration molarity is equal to what? Mole per volume in liters. So 1,000 liters is given. We'll be dividing 2 to 10 to the power minus 5 over 1,000 equals 2 to 10 to the power minus 8. 2 to 10 to the power minus 8 of hydronium. In this case, hydronium is less than 10 to the power minus 7. That's why it's the basic solution. The other question, the next one, guys, a ministerial exam question, 24-25 rounds of ministerial, said a quantity of calcium hydroxide is given here in this question. How to calculate the hydronium? How to calculate the hydronium? So simply we will be converting this into hydroxide, and then by Kw we will be finding the hydronium. That's calcium hydroxide is 2OH. It contains 2OH. That means the hydroxide concentration is 2Y. So we can say the hydroxide concentration equals the 2 to 10 to the power minus 3 molarity. As we review with the hydroxide, we'll be able to calculate the hydronium, which equals 1 to 10 to the power at 25 Celsius, of course, 10 to the power minus 14 divided by 2 to 10 to the power minus 3, so equals 5 to 10 to the power minus 12. That's the correct answer for this question, guys. Based on the provided equations that we talked about them, we can calculate any type of question mathematically which appears in ministerial exam question, guys. All of the following solutions are acidic except one of them. So 3 of them are acidic, but one of them is not. Choose that one. Hydronium equals 10 to the power minus 5. Yes, it's acidic. It's incorrect. The hydroxide 10 to the power minus 10. Yes, because hydronium will be 10 to the power minus 4, acidic. pH less than 7, acidic. Hydronium 10 to the power minus 7, it's neutral, not acidic. So this is the correct answer. And the last question in this slide, it talks about the correct order of pOH for the following salts, guys. We should know that we talked about the salts. NaCl is neutral, okay? CS3COOK is basic, alkaline. And then NH4NO3 is acidic. The salts, the arrangement according to pOH is from the acidic toward the alkaline. The acidic is the most pOH, then neutral, then alkaline. So as you can see that here, the acidic comes first, more than the neutral, and then the basic one. So B is a correct answer. Let's solve more questions of ministerial exam. If pH of seawater at 25 Celsius is 8.3, which of the following is correct? 8.3, the seawater is basic? Yes, because 8.3 is basic. B is correct. How to convert into hydroxide, guys? pH, we will be converting into pOH, okay? Equals 14 minus 8.3. So in this part of the question, 14 minus 8.3, it's equals to 5.7. This 5.7 will be converting into the hydroxide concentration by taking the hydroxide concentration equals 1 to the power minus pOH, okay, or anti-log of minus pOH, guys. I'll be calculating this. Minus 5.7 is equal to 2 to the power 9, 1.9 to the power minus 6. So A is correct also. That we can say that D is a correct answer, which is both A and B. The next question, guys, we can say that a ministerial exam question. The next one, let us solve next questions. The next coming questions. The required mass is a requirement for this solution of calcium hydroxide. the volume is given and the pH is given. The pH is given, we can say pOH is equal to 1 because, yeah, and hydroxide is equal to 1 10 to the power minus 1, okay, or we can say 0.1, okay, guys. If the hydroxide is known, how to convert into the concentration of calcium hydroxide? Because the mass equals the mole multiply molar mass. Multiply molar mass. The molar mass is given, okay, 74. We should find the mole. 0.1, it's concentration of hydroxide. How to convert into concentration of calcium hydroxide? Divide by 2 will be 0.05, okay? And then that 0.05 multiplied by 74, you'll get the mass, which is 1.85 grams. The next question is about which of the following is acid at 25 Celsius? Based on the provided relations that we talked about, we can solve this question. pH equals 12 is not acidic, it's basic. pOH 3.5, it's not acidic, it's basic. Hydronium is neutral. And then hydroxide 10 to the power minus 12, it's acidic because the pH of that will be the 2. Ministry of Exam question, the last one. Which of the following is correct for calcium hydroxide solution with 2 10 to the power minus 3 molarity, guys? Hydroxide is equal to 2 10 to the power minus 3? No, because it's twice as the hydroxide is twice as the concentration of the base. pOH is equal to 2.7? No. Hydronium is equal to 5 10 to the power minus 12? No, it's incorrect. And then pH equals 1.11.6. Yes, that's the correct answer. Thank you for the attention.